University is responsible for the soil characterization and classification related tasks. This is the second part of our planned webinar series, fourth in a row, but the second in the webinar series that Mate is leading. The topic of the first webinar was soil forming factors and soil forming processes. And as you can see from the first slide, this is the foundations of soil observation. So the first one was soil forming factors and soil forming processes a few weeks ago. And the second that is going to be had today is soil forming processes and soil horizons. You are going to see that the first webinar, the topic of the first webinar is strongly connected to the second webinar, to the topic of the second webinar that we have today. I would like to start with a recap, because I think we had our first webinar 3 or 4 weeks ago, and it would be good just run through quickly on the key terms that we discussed last time, so it would be much easier to understand what I'm going to explain today. So last time we discussed the soil forming factors and soil forming processes, and we discussed these terms to understand why soils differ from place to place, that is why we had to understand soil forming factors and processes. I won't go into very deep details. As you remember, soil forming factors are those environmental factors that define what kind of soil can form at a given point of the earth. And in short, these 5 factors are the parent material, topography, the climatic conditions, biological activity, and the time. These factors interact continuously. So these are those ones that define the environmental conditions under which soils form. So if we understand these factors, we can already have ideas on the properties of those soils that we are going to investigate on the field. And it's very important that soil forming factors are those factors that drive soil forming processes. Soil forming processes are responsible for the development of horizons in the soil and define the soil properties. So these two factors and processes, they act together, and they are together responsible for the soil genesis. And the soil forming processes, for example, weathering, leaching, fertilization, are responsible for the development of the horizons in the soil, which are the topic of today's webinar. Just we ran through the major soil forming processes that we discussed last time. Intense chemical weathering. It's a dominant soil forming process in Liberia because under hot and humid conditions, mineral alteration is very strong. This is the foundation of, this is the starting point of any soil formation. Another very important soil forming process in Liberia is leaching. During leaching, high rainfall causes continuous downward movement of water through the soil profile. Soluble bases like calcium, magnesium, potassium, and sodium and silica are progressively removed from the topsoil, which can lead to acidification, nutrient depletion, low base saturation, and strong chemical differentiation. And as I mentioned, this is one of the fundamental drivers of soil development in Liberia. Another very important soil forming process in Liberia is clay translocation. Clay particles are dispersed in the upper horizons and transported downward with the downward moving water, and clay minerals accumulate in the subsoil horizons. The indicator of the clay movement in the soil is the increase in clay content with the depth and the visible clay coatings on the aggregate surfaces. This process leads to the development of clay-enriched subsoils. Another important soil forming process is humification, because this is that process that leads to the development of the organic matter-rich topsoil. This is that process that is responsible for the formation of the dark surface, humus-rich horizons, the accumulation of humified organic matter near the surface, and the field indicator of having this soil forming process is, of course, is having a dark surface A horizon, a good structure. Ferrolitization is the next process that we discussed last time. This is also a very dominant soil forming process in Liberia, and it's a dominant soil forming process across the humid tropics globally. This process is basically a strong tropical weathering process in which silica and bases are progressively removed, while iron and aluminium oxides remain and accumulate residually. As I mentioned, this develops under warm and humid conditions, and the typical field indicators of having these soil forming process are the typical deep red and yellowish colors, very deep soil profiles, uniform clay distribution, very low fertility. Plintite formation and cementation by iron. It is related to the fluctuation of the groundwater or seasonal water saturation. During these processes, iron is mobilized and later segregated. And repeated wetting and drying can cause iron concentrations to form soft plintite, which may irreversibly harden when it is exposed to the air. Field indicators of this soil forming process is the presence of reddish mottles, soft or hard iron nodules, hardened or even cemented layers in the soil, cemented by iron. Very important soil forming processes, redox processes, and glaying or glaciation. In poorly drained environment where oxygen becomes limited, the iron is reduced under water saturated conditions, and it's reoxidized when oxygen returns. On the field, we see grayish, bluish, or greenish matrix, soil matrix colors, and reddish, rusty patches in the soil. This process is typical in valley bottoms and depressions. Peat formation. In permanently saturated environments, decomposition, so organic matter decomposition slows down because of oxygen-poor environment, and that is why we see organic residues, the accumulation of organic residues. This process can lead to the development of thick organic layers, dark material in which we can see the original structure of the plants and peaty horizons. It is less common in upland than in the humid tropics. Mostly it occurs in swamps and in wetlands. Nitization is a humid tropical soil forming process that produces stable, well-structured clay-rich subsoil. This leads to the development of this very good, strong, well-developed blocky structure and high clay content subsoil.